In GSM, there's a range of numbers and identity codes which are required for the provision of the basic procedures in a digital mobile network. The following aspects must be considered: the identity of a subscriber, the services required by the subscriber,
the national or international location of a subscriber, the localization of the subscriber in relation to various base stations or other network elements, and the mobile station used by the subscriber. There are several numerical identities for these aspects that will be introduced in the course of this chapter. The international telephone number of a mobile GSM customer is his mobile subscriber ISDN number, or MSISDN. The number is only stored in the HLR of the home network and is never intended to be transmitted on the air interface. How do you dial this number from a public switch telephone network, or PSTN? First, dial a prefix to distinguish between national and international calls. For national calls, the prefix is usually 0. For international calls, it's 2 zeros and 2 or 3 digits depending on the country. In GSM networks, it's sufficient simply to enter a plus sign instead of the 00. The second part of the MSISDN, the Mobile Country Code, MCC, provides the code for the relevant country. The MCC consists of 2 digits and doesn't have to be entered when making national calls. The third part of the number is the Network Destination Code, NDC. It identifies the appropriate national network operator. The Mobile Subscriber Identification Number, MSIN, forms the fourth part of the MSISDN. The first 3 digits of this number determine the logical HLR where the GSM customer is stored and which is used to locate him or her. The remaining digits identify the individual subscriber, with different services like speech, fax and data services requiring different MSINs. To identify a GSM subscriber in a mobile network, each subscriber has its own International Mobile Subscriber Identity, IMSI. The IMSI is of a standard length of 15 digits and is composed of the following elements: a Mobile Country Code, MCC, with 3 digits, a Mobile Network Code, MNC, with 2 digits, and a Mobile Subscriber Identification Number, MSIN, with 10 digits. The IMSI is required for registration in a PLMN because it's defined as an individual number code with a uniform string length of digits. The MSISDN, by comparison, has differing length of digits depending on the country, and therefore cannot be considered for a simple registration procedure. Furthermore, a customer has different MSISDNs for every service, but only one IMSI that can uniquely identify him internationally. MSISDN and IMSI are stored as permanent database entries in the Home Location Register, HLR, of the customer's home network. The HLR also contains information on the services for which the customer is registered. These are static entries. In addition, a database field is reserved for the current VLR address. This entry is dynamic and is updated depending on the location area where the subscriber is. In this way, the HLR always knows the current location of the subscriber, and thus enables the routing of calls to the relevant MSC. The Mobile Station Roaming Number, MSRN, is a temporary number produced for routing the call in case of a mobile terminated call. MSRN is generated within the serving MSC VLR, that is, where the mobile station just happens to be at that moment. In order for a called subscriber to be identifiable, the MSRN is linked to the International Mobile Subscriber Identity, IMSI. In the event of an incoming call, the MSRN is transmitted via the HLR to the Gateway MSC, GMSC, to inform it where the call has finally to be routed. The MSRN has the same structure as the MSISDN. It consists of the country code, CC, the National Destination Code, NDC, and a subscriber number, SN, that is different to the SN in the MSISDN. While the MSISDN only establishes a connection to the HLR, the MSRN is used to route the call to its actual destination. If a mobile subscriber, while making a call, moves from one MSC area to another that's covered by a different VLR MSC, an inter-MSC handover is required. That is, the transfer of the call from a currently serving MSC, or the anchor MSC, to the new MSC, the target MSC. The anchor MSC stays responsible for all call control activities, so it has to know where to route the call. To support this, the target MSC generates the handover number HON and sends it to the anchor MSC. Using this number, it can now create a connection to the target MSC. Like the roaming number, it's made up of the country code CC, the National Destination Code NDC, and a subscriber number SN, which is also different from that of the MSISDN. The Temporary Mobile Subscriber Identity, TMSI, and the Location Area Identity, LAI, are required for the location update of a mobile station. The TMSI is generated in the VLR of the relevant hosting network after the first location update, and then linked to the IMSI. From then on, the IMSI is no longer transmitted for data security reasons. Instead, the TMSI is transmitted via the air interface. This is the temporary identity of the mobile radio user. It's assigned for the mobile's presence within the location area. The Location Area Identity, LAI, is a unique number worldwide. The net sends it via the control channels of the air interface to the mobile station, so the mobile station recognizes its current position and can store it on the SIM card. The International Mobile Equipment Identity, EMI, is stored on the hardware of the mobile station and is used to check the validity of the relevant terminal used. In the Equipment Identity Register, EIR, the same number is stored to check number compliance. This equipment check is optional in GSM, and not every network operator offers this service. The EMI contains a check code, the type approval code, a terminal number, the final assembly code, and the serial number of the mobile station. The Cell Global Identity, CGI, is a number code used to identify each cell within a location area of a GSM network. The CGI consists of the relevant mobile country code, MCC of a country, the mobile network code, MNC for relevant network, the location area code, LAC of a location area, and the cell identity, CI, which indicates the relevant cell within this location area. Using this code, the traffic data relevant to a cell, for example, can be evaluated statistically in the Network Management Center, NMC. If a mobile subscriber is at a certain location, his mobile phone usually receives frequencies from different network operators. In order for his mobile phone to synchronize to the frequency of its own network operator, each base station must be able to identify itself. This identity is the Base Station Identity Code, BSIC. It's broadcast by every BTS and compared with the appropriate entry on the SIM card of the subscriber. Only after verification that the broadcast BSIC is identical with the entry on the SIM card can a mobile station be registered on the network. Furthermore, the BSIC has to make a distinction between the serving cell and those other cells that use the same frequency as the serving cell. It consists of the network color code, NCC, and the base station color code, BCC. In order for a user to be able to use a mobile station, it must be registered on the network. After a subscriber has switched on his mobile phone, he first enters his PIN. The PIN is stored on the SIM card. This step will not access the network. The mobile station only begins communications with the network after successful PIN query. Network Search appears on the display of the mobile station. To select the radio cell, the mobile station measures all broadcast control channels that have been sent on all frequencies from all network operators. Then, a suitable network PLMN that's authorized for the subscriber is selected. In the home country, this at first is only the network of the subscriber's own network operator, then the network of a contract partner. Now, the mobile can select a suitable cell from several possible cells. After a successful location update, the mobile station is in idle mode. Let's have a closer look at the location update procedure. Irrespective of where a mobile subscriber happens to be, a caller must always be able to contact him or her. This means the mobile network must always know the subscriber's current location so it can put through calls. By subscriber's current location, we understand in this context the appropriate location area, that is, the area controlled by a certain VLR. A VLR controls at least one location area. However, in order to define as accurately as possible a subscriber's current location, the VLR area usually consists of several logical location areas. The process that keeps the network up to date as regards this current location is called location update. A location update is carried out when a mobile customer switches on his or her mobile station, when a mobile customer changes his or her location area, and at regular intervals after a mobile customer has not moved his or her mobile station for some time. What information is exchanged between which network elements during location update? The mobile station sends, via the BSS and the appropriate serving MSC, a location update request to the controlling VLR. This then requests a subscriber ID stored on the SIM card of the mobile station, which is sent immediately to the VLR. Now, the VLR can request the authentication data, also called the authentication triplet, from the subscriber's HLR AUC. After receiving the reply from the HLR, the VLR sends the authentication data to the mobile station. After successful authentication, the location update, in the form of the VLR address, can be sent to the HLR of the subscriber as the current location. Let's have a closer look at the authentication process. A new serving VLR requests authentication from the SIM card used. This request is forwarded to the Authentication Center AUC of the home network, which will provide the VLR with an authentication triplet. The triplet consists of a random number, RAND, a signed response, SRES, and a key, KC. SRES is the calculation result of the algorithm A3, combining the individual key, KI, stored in the AUC, and the random number, RAND. KC is generated in the same way by the algorithm A8 using RAND. Several of these triplets produced this way are transmitted to the inquiring VLR. The VLR first stores both parameters from the triplet, KC and SRES, for later use, and only transmits the random number RAND to the mobile station. Using this number and the information stored on the SIM card, that is, the algorithms A3 and A8 and the key KI, the mobile station can produce the same parameters as the AUC, namely SRES and KC. For authentication, the mobile station sends the SRES it's produced back to the VLR. The key KC is used later for channel encoding. Now, the VLR can compare both SRES numbers, one from the mobile station and one produced by the AUC. If both parameters tally, authentication was successful. Finally, the TIMSI is transmitted in encoded form. We refer to a mobile terminated call, MTC, when a mobile subscriber is being called. Let's look at the MTC using a call from a PSTN as an example. First, a PSTN customer dials the number of a mobile phone. The number dialed is the MSISDN. The exchange of the Public Switched Telephone Network, PSTN, analyzes this number and contacts the Gateway Mobile Services Switching Center, GMSC, that is, the link between the PSTN and the mobile network. The GMSC doesn't know the current location of the called subscriber, and therefore starts an appropriate inquiry to the HLR of the called subscriber. The HLR checks its database entries to find the current location or the currently serving MSC VLR of the called subscriber. Now, the HLR asks the serving MSC VLR for the routing information necessary for the call connection. The serving VLR now generates the temporary Mobile Subscriber Roaming Number, MSRN, and sends it via the HLR to the GMSC. The GMSC now has the routing information it needs and transmits the call onwards to the serving MSC. The VLR makes the LAI available to the called subscriber. To locate the called subscriber, the MSC initiates a paging process within location area. Let's have a closer look at this process. The MSC initiates the paging in the entire location area using the Temporary Mobile Subscriber Identity, TMSI. This is made available by the VLR and is also known to the called mobile station. It's been allocated to a subscriber after the first location update of his mobile station and is used instead of the IMSI for data security reasons. Within the relevant location area, the TMSI of the called mobile station is broadcast on the air interface via the paging channel PCH. However, as the TMSI is clearly allocated within the VLR area, and thus also within location area, only the called mobile station can identify the paging channel and react accordingly. The called mobile station reacts to the paging channel with a request to the network for a free channel. This request is sent via the Random Access Channel, RACH, in an uplink to the BSS. This allocates, through the Access Grant Channel, AGCH, a stand-alone dedicated control channel, SDCCH, to the mobile station. This communicates with the BSS via the SDCCH, which exists both in the uplink and the downlink, until a traffic channel is allocated to the mobile station. Parameters for authentication and encoding, as well as the new TMSI, are transmitted via the SDCCH to the mobile station. If this is concluded successfully, the actual call setup is initiated. For this purpose, a voice link is established between the mobile station and the BSS by allocating a traffic channel on the air interface. Let's have a more detailed look at the various steps of call setup. First, the mobile station is informed that an incoming call requires a call setup. This setup message is sent to the mobile station via the SDCCH. The mobile station confirms the setup inquiry in the uplink via the same channel. Now, the MSC selects a terrestrial channel of the A interface, also called a trunk, for the transmission to the BSS. It sends a message, an assignment request message, to the BSS, asking it to allocate a free resource on the air interface. This message contains information on the trunk used, so later on the data stream functions perfectly. After receiving the assignment request message, the BSS allocates a suitable traffic channel and transmits this allocation via the SDCCH to the mobile station. This must now prepare itself for a configuration of its air channel. The mobile now takes over the allocated traffic channel and transmits the confirmation of the allocation to the BSS via the FACCH. Now, the subscriber is informed for the first time by the man-machine interface, MMI, of the incoming call. In other words, the telephone rings. The BSS transmits a final confirmation message to the MSC about the successful allocation of the air and terrestrial resources. If the channel allocation is unsuccessful, the BSS sends an appropriate error message to the MSC about the reason for the failure. Possible reasons for a failure are that either air or terrestrial resources were reserved previously and are thus unavailable. speech, and signaling data are not transmitted in their original state on the air interface, but are encoded. Only after successful authentication can the BTS and the mobile station start the encoding process. The 114-bit key used for encoding and decoding at both ends of the air transmission is produced at the BTS and at the mobile station using the encoding algorithm A5. For this purpose, A5 uses the 64-bit key KC that was generated during the authentication process, and a 22-bit TDMA frame number in order to encode and decode speech and signaling data. We refer to a Mobile Originated Call, or MOC, when a mobile telephone subscriber calls a subscriber on the Public Switched Telephone Network, PSTN, or on a Public Land Mobile Network, PLMN. The mobile caller dials a number. This means he starts a call service inquiry in the net where he's currently a visitor. Then the net analyzes the caller's subscriber data to do three things: to authorize or refuse the use of the network, to activate the requested service, and to route the call. If the call is addressed to the same mobile network, the MSC turns to the relevant HLR via the dialed MSISDN to send the call to its destination. If the call is to the PSTN or to a different PLMN, it's routed there via the gateway MSC, GMSC, and sent on to the target subscriber. If a call is made to a PSTN, the following communication procedures take place between the network elements. First, the BSS and the mobile station agree on channel allocation. When this is done, necessary safety checks relating to the subscriber are carried out between the mobile station and the serving MSC VLR. The mobile check is optional, depending on the network operator. The EMI, which is transmitted in encoded form through the air by the mobile station, is sent to the Equipment Identity Register, EIR, that checks the authorization of the terminal used. Only after the security checks have been carried out can the mobile station start the call setup via the MSC. This now checks, in the connected VLR, whether the subscriber is authorized for the desired service. If the VLR sends back a positive reply, the call setup can be carried out, and a traffic channel can be allocated to the connection. The serving MSC sends the call via the relevant GMSC to the exchange of the PSTN. If a confirmation of successful call setup is sent from there, the caller is informed by his MSC, and he hears the calling signal on his telephone. The conversation can start. We know already that the GSM network is of a cellular design. If a subscriber moves from one cell to a neighbouring cell, the current connection must be maintained without any interruption. To ensure this, there is the handover. That is, the neighbouring cell takes over the coverage tasks in a sort of substitution without stopping, and the connection to the original cell is interrupted. Handovers occur in the following cases. A handover due to transmission measuring results occurs when the signal strength or its quality is too low, or the distance from the mobile station to the BTS is too great. The call is then transferred to a neighbouring cell. A handover due to high traffic volume within the cell occurs when the capacity of the cell is exhausted, and the call is transferred into a neighbouring cell which is less busy. When necessary, a handover can be forced by the OMC, due to maintenance work in the cell, for example. A distinction is made between various handover types. We'll look at them in more detail in the following lessons. The smallest of all handover types is the handover within a cell, the intra-cell, intra-BSC handover. In this case, a subscriber is diverted to a different traffic channel within the same cell. Generally, this channel is generated with a different frequency or time slot. The decision about the handover is made by the BSC that controls the cell. The inter-cell intra-BSC handover takes place when a mobile user moves from one cell into a neighbouring cell, both controlled by the same BSC. The traffic connection to the old cell is discontinued as soon as the connection set up to the new cell is successfully completed. This process is controlled by the BSC. We refer to an inter-cell inter-BSC handover when a mobile user moves from one cell to a neighbouring cell that's controlled by a different BSC, with both BSCs being supervised by the same MSC. This type of handover is carried out by the operating MSC, but the decision about the handover is made by the old BSC. The connection to the old BSC area is only interrupted when the new connection has been successfully established.